Hello everyone, this is Anshka Gupta and welcome to my channel Let's Code and Solve by Newton School. I hope all the tutorials have been clear to you. Today we're going to study about what is exponential distribution. Before going to that, let's know what is Newton School. So Newton School is a platform which prepares you for career in tech. It has courses designed for freshers, working professionals, and also for women with non-tech background. Newton School first trains you for 6 months and helps you to become amazing full-stack developer. It also has a network of more than 300 great companies who hires from Newton School. So once the training is complete, Newton School also ensures that the students are placed with some of the best companies in the country. And the best part is the Newton School has a pay after placement program under which you don't have to pay Newton School anything until or unless you are being placed with minimum 5 lakh CTC. So the top companies where you are being placed are, here you can log in and sign up yourself. The top companies where you are placed are Xiaomi, 7-Eleven, Rapido, Mysore, Motorola, Lenskart and many more. Now let us shift to our concept, that is exponential distribution. So moving toward what is exponential distribution and what is the role of exponential distribution nowadays. Exponential distribution is rolled and ruled the country with a lot of languages in every of that. So in every probability, in every theory of statistics or any of the distribution and that, exponential distribution is the probability distribution on time between events in a Poisson point process. See, we read about the Poisson distribution also. Then we read about some of the mode distribution or multinormal distribution and many more. So what actually they are being refers to the exponential distribution. So it is just a time between the events such as Poisson point SS. That is the point where the process is being taken with each of the events continuously and independently at every constant average rate. Okay. Now while processing to that, it has to be configured out whether the point is being given to an exponential distribution is correct or not. So exponential distribution is just and potentially divided between the probability distribution of the time between the events, that is the whatever we can say is, and the gamma distribution or any of that. So it is just continuously or independent at the constant average rate. Every particular case of the gamma distribution is a continuous, analogous and the geometric distribution. The key point, the key property of being memoryless is the characteristics of your gamma distribution. In addition to being used to the analysis of Poisson point processes, it is found that each of the various other contexts, so same the class of exponential family of distribution, that is the larger class of your probability distribution, which includes more of your distribution between the numbers, normal distribution, binomial, gamma distribution, and there are a lot of that. So the exponential distribution is a continuous distribution that is commonly used to measure much more expected time for an event to occur. For example, in our exponential distribution, there is a point known as radioactive decay. It is the most common example of your exponential distribution, that is radioactivity decay. Whether these are being done with the scientific or not, that depends. Okay, every geometric distribution has in various part of that. Okay, various, and the conditional part has been given by the exponential distribution. Now here are the graphs representing the probability density function and cumulative distributions function. So this is the probability density function and this is the cumulative distribution function. So here the graph Here the graph has been given from upper to lower, and here the lower to upper, where decising the destructive property of lines. Okay, every part of the line has been given to the lambda function, where the lambda function has been approving. So lambda is in just in rate of inverse scale, whether the inverse scale is to be applied in this or not, that depends upon the condition. Okay, every exponential is not the same as in class of exponential families of distribution, which is the large class of probability distribution that includes the exponential distribution as one of the member in that. Okay, but it also includes many more advantages in that. Now, how the occurrence of events are being there? For the occurrence of the events, the exponential distribution occurs only and only naturally when describing the length of interval time as a homogeneous Poisson process. The more the exponential distribution will be viewed by the continuous counterpart of the geometric distribution, the more will be the Bernoulli's trials in a discrete process to change any of the state in that. Okay, in contrast to that, every exponential situation or distribution is in continuous process to change the state of it. Okay, the assumption of constant rate is there, that is the probability per unit time, that is being satisfied with more oftenly accordingly it is the roughly constant. Okay. Similarly, it has been applied and yield to the approximately exponential distributed variable, that is the time under radioactivity, that particle decay, or the time between the click of Geiger counter. Okay, second, the time it takes before the next call or any of that. Now, in a theory of queuing theory, there is a theory in physics also, in programming also, the queuing theory, that depends upon the service times each of the agents in a system. Okay, so if the interval of time of the independent and distributed is identical, that is a Poisson distribution that will arrive with an instance. Okay, relatively each of your theory and each of your execution made by an extensive part is being suited to your model. Okay, and it is hazardous too, because you don't know like how your program is going to execute with which of your the program association. The exponential distribution is however not appropriate to model the overall lifetime of organism or technical devices, because the failure rate here isn't like are not constant in that. More the failure occur for very young or more the old part. So what is refractory period in your exponential distribution? It has been assumed like whenever there is a high probability density, there is a shortage of ISI. Okay, every refractory period has been represented by the expected value of the exponential distribution with random variable x, the rate period of the lambda given by Ex is equals to 1 by lambda. Okay, it depends. The variance, you know, it is a square of your denominator, so it will be 1 by lambda square. Okay, however, every part is not a memoryless, that is the distribution given to the obey the relation of that. One of the most common problem in your exponential distribution is your data mining, that is modeling the occurrence of the significant events. See, when t has been interpreted as a waiting time for an event to occur the relative initial time, that is more importantly because the relation implies that if t condition is failure to observe the event or over the initial period is time s, it has been given that the denomination or the deformation period, the period time is being unconditional in that. You can also calculate the probabilities easily according to the properties of each of your exponential distribution. That is, the calculation of your probability are not additive. Okay, you must find it to combine with interferences or different probabilities, or more often the application of that is must be the insurance credit system. Okay, there is an interesting relationship between the exponential distribution and the Poisson distribution. I already told you 1 by lambda and lambda square. Suppose that the time that elapses between the two successive events follows the exponential distribution with mean of mu, unit of time. Also assume that these times are independent. Okay, meaning of that time between the event is not affected by the time between the various events. If the assumption hold, then the number of events per unit time follows a Poisson distribution with mean of mu. Okay, see in the previous video also, just check that. I told you that you have to recall if the x has a Poisson distribution with mean mu, then the formula for the exponential distribution, where m will be your rate of parameter and mu will be your time between the occurrences. Okay, we can see the exponential as a major difference and an important difference that make each of your distribution the relevant for different types and the probabilities of problem. First, the Poisson has been the discrete random variable. Then x, where the time is there, a continuous variable is artificially broken in that. Okay. However, the more of the discrete function is there or the occurrence is there, the more the interval time is spent by. I hope it has been clear to you. Thank you for watching the video. Subscribe to my channel, like the video and stay tuned.